is the topic under trig. So in this particular lesson, I'm going to be revising you with the topic on trigonometry. And again, before I begin the lesson, guys, I just want to encourage you, if this is your first time to come across our channel, I'll encourage you to subscribe to our channel as well as to turn on that notification bell, as this enables or it allows you to be notified every time we have a new video that we're posting. So if it is your first time and you have not yet registered, or in a way you have not yet subscribed, that's the right word, if you have not subscribed to our channel, I will encourage you guys to subscribe to our channel so that you can be able to benefit from these videos. And now let us look at this grade 11 topic. As I said, I'm focusing on trigonometry, and I've got this question number 5, which is out of 28 marks, and I want to show you some strategies and ideas that you can use to answer such questions as you guys are preparing for your final exams. So let us look at this question 5 here. So okay, so this is question 5. It's a common question, but a very important question, as it also you will find it in your grade 12, but the foundation that they need is for you guys who are in grade 11. So in grade 12 you are not taught this part, but it is already assumed you did it in grade 11. So if you understand it at this stage, you must know that it is a very big advantage as you also approach your grade 12 in the following year. So let us look at question number 5.1. This question 5.1 here, it says in the diagram below, t, which is x15, so you can see we've got t here and we've got x, and 15 is a point on the Cartesian plane such that OT is equal to 17 units. So we've got this OT, that distance, they're saying it is 17 units. So if I can mark that, so we have that distance being 17 units, and then they're saying P, which is in this case minus 2a, you can see the point P here lies on OT. K, which is that point there, is a point on the positive x-axis, and TOK is called to theta. So there is that angle theta, you can see that line TOK. So the angle there that is formed is theta. So now let us look at the questions that they are bringing in concerning this diagram. So they are saying determine with the aid, so look at the questions now, you must determine with the aid of the diagram the following. So in this particular question they have already sketched you the diagram. Some other questions they want you to start from scratch, whereby you need to sketch the diagram from the information below, but this question, the good thing is already they have sketched you the diagram. So the first thing is here is says with the aid of the diagram determine the following, and the first part they are asking is to find the value of x. Look at that. So they want you to find the value of x, and how do you go about finding that value of x? So as I said, it's a common question. It's 2 marks, as you can see that. And for you to be able now to find, to get those 2 marks, because the aim is to ensure that you get everything correct from the start. So 5.1.1, find the value of x. So now if I want to find the value of x in this case, what I need to do, if I can have complete my triangle here to say, if I had it like this, alright, and then like that, and like that, just to say, let me have it as a full triangle like this. So what I have in this particular scenario, this is my 90 degrees, and remember this represents my x and represents my y, and this 17 represents my r. So now I need to use the theorem of Pythagoras. Remember, this is a right angle triangle, and with the theorem of Pythagoras, r squared is equal to x squared plus y squared. It will help me to find my x and y. So now where there is r, remember, okay, let's look at t here, because I'm given t as x and 15. So you know that the coordinates are x and y. So you can see that already I've got the y value. So 15 is my y value there. So already I have my y value being, in this case, 15, as you can see that. So it makes it easier if I can just make it clear there to say my y is 15 there. Alright, so now I can be able now to find the x value. So where there is r, I've got 17 squared is equal to x squared, which is what I want to find now, plus y squared, which we agreed it is 15 squared. It's better to put it in brackets like this. And then if I have 17 squared, take 15 to the other side, it becomes minus 15 squared is equal to x squared. And then I have to find now what is 17 squared minus 15 squared. If I can use my calculator here, which is 17 in brackets, don't forget the brackets, guys. It's 17 squared. I need to put the bracket like that. 17 squared minus 15 squared, I get 64. So I've got 64 is equal to x squared. So how do I find x? Now for me to be able to find x, I need to square root on both sides. So I have to square root and I have to square root. But when I'm square rooting, don't forget I must say plus or minus. Very important part. Don't forget that. You need to say plus or minus so that you can find x. So you'll see that square root of 64 is 8. So the answer is plus or minus 8 is equal to x. You'll see the reason why I'm saying you need to put the plus or minus. If you forget the plus or minus, you will make some errors. So now when we come back to our diagram here, you know that our value of x was equal to plus or minus 8. So if I can come to this diagram and ask myself, which is the suitable value of x, you can see that in the Cartesian plane, in this direction, it is negative, and in this direction, x is positive. So now you can see that x is on the negative side, so the only value of x that is possible is minus 8. So you see the importance of saying, is it plus or minus 8? Then you can choose the right value of x, and x is equal to minus 8. So here you can say, therefore, x is equal to negative 8, because the question here was find the value of x. And you can now conclude, in this case, after the calculations, you can conclude that x is equal to negative 8, as you can see that. So that is the first part. Let us move on to look at question 5.1.2. All these questions will be based on this diagram. Now looking at 5.1.2, now they want to find tan theta. Now for you to find tan theta, remember tan theta in terms of x, y, and r is equal to y over x. This you must always remember. Tan is always the opposite, which is y, over adjacent, which is x. So when you're given that, now you know the value of y, remember, is 15 over, now x is negative 8. So that's why it's just 1 mark. So to get that 1 mark is just to input 15 over minus 8 as tan theta. So that is the value of tan theta. Moving on, 5.1.3, cos 180 minus theta. Remember how you simplify cos 180 minus theta using the reduction rules, because that's what you need to use here. Cos 180 minus theta is in the second quadrant, and in the second quadrant, if I can remind you of the cast diagram here, because I'm using the cast diagram to have that. If I can have let me just have some space here for my cast diagram. Let me do it here. So if I can remind you of the cast diagram, guys, like this. Remember, in the cast diagram we say all students take chemistry, and then in this we've got 0, we have 90, it's anti-clockwise, we have 180, you have 270, and you have 360. This is very important for you so that you can have some reduction rules easier to simplify. So in the second quadrant, it is where we have here 180 minus theta, and then in the third quadrant, because this is the first, this is the second, the third, and the fourth. So in the fourth quadrant, that's when we have third quadrant is 180 plus theta, and here we've got 360 minus theta. In the first quadrant, we have got 90 minus theta as the other one, and then also in the second quadrant we have got 90 plus theta. I'll put these and circle them like that. But what we are looking at in this case, we are looking at cos 180 minus theta. As you can see, it is that. Now you can see that in the second quadrant only sine is positive, meaning cos is negative and tan is negative. So when we simplify that with using the reduction rules, this is equal to minus cos theta. So there is the negative that I'm getting from, so it's negative cos. So if I continue, this is minus. Now cos is in terms of x, y, and r. Remember, cos is adjacent, and adjacent is x over hypotenuse is r. Where am I getting that? If I can come back to the diagram that we were working on, you will see that in this diagram here, the x represent the cos, the x represent the adjacent, not the cos. I wanted to say the adjacent side, so it's adjacent, and then the y represent the opposite, and then the r represent the hypotenuse. Always remember that. That's why when I'm saying cos, and then you come back to the word SOHCAHTOA, so ka, and then toya. So when you come to cos theta is equal to a, then you put an over, it's over. So it's a, which is a adjacent, over h, which is the hypotenuse. That's why I'm saying this, then the adjacent, as you see, a is x over hypotenuse is r. So that's how I'm working it from there. So if we now use our values, remember we said what was x, we calculated that x was minus 8, so which is equal to minus bracket x is negative 8 over r was 17. So if you simplify this, equal to negative and negative is positive, so it's 8 over 17. So the answer is positive 8 over 17. So that is how you could have solved that question, guys. So let us move on. I have to erase some of these. Okay, let me try to keep it like that. Maybe some questions will still require that. But let's look at the next question, which is 5.1.4, sine squared theta. Now for me to be able to solve sine squared theta, just find some space at the bottom. Now sine squared theta is equal to, now when you're given it like that, always have it back to the way it is supposed to be, because it's sine theta squared. That is how your calculator can simplify that. Now sine theta, remember, we come back to our SOHCAHTOA here. You can see that sine theta is equal to O over h, which is opposite over hypotenuse, and opposite is y over r. So that's what you have. So when you come here to sine theta, you're going to say it's O. Now opposite which is y over r squared, which is equal to, now y we said was, if you go back to our diagram, y was 15, r is 17, so you have got now in this case 15 over 17 squared. Now the question was with the aid of a diagram, okay, so they didn't stop you from using a calculator, so you can use a calculator now to say what is 15 over 17 squared, and then it will give you 225 over 289. So we have 225 over 289. So you see how you're simplifying this question. So the approach, as I say guys, is very important. You need first to have your your x, y and r values in check. The moment you do that, you won't have a problem. Now 5.1.5 says the value of a. So in this case, we go back to the diagram, and in the diagram you see that we have this part where p is equal to minus 2a. So they want us to find the value of a, and there are many options you could have done. You could have even come here. I think I can now erase this part. I can come here. Let me erase just a part of this. I can come at this stage, and remember tan theta is equal to minus 15 over 8, and that was my tan theta, and p is also on the line of t. So you can see that p and t are on the same line. So I can actually say in here, if I want to find tan theta in terms of p, and remember, let me use p here to say my p is equal to minus 2a, and let me write my t is equal to x and 15. But remember, I know my x now. My x actually is negative 8. So look at this now. When I used t, I said tan theta was equal to, this is y, this is x. So it was 15 over minus 8. So are you seeing that? That is how I managed to get my tan theta as that answer. But I can also use the same concept, and the same concept I'm going to use here to say where there is a 2 is also my x, and then my y is represented by a. So I can use the same, because it's on the same line, and then say tan theta is equal to, now what do I have here? I have got y, which is a over minus 2. So are you seeing what I'm having there? Because that's what they gave me. So this is my tan theta, and this is my tan theta. At this stage, I'm able to equate the two here. I can equate to say these are equal, and then it means at this stage, therefore, minus a over minus 2, this part is equal to, because this is also another tan theta, 15 over minus 8. See that? You can actually use this part, and then you have to solve for theta. It's up to you how you solve it. So this is one way you could have done it, but there are many different ways you could have approached this. So now when you do that, cross multiply like that, a times minus 8 is minus 8a is equal to minus 2 times 15, which is negative 30. Divide by negative 8 on both sides, so that you can get your a, so that you've got a is equal to, that cancels, and you can use a calculator to simplify. What is, it's negative 30 over negative 8. I think it will give you 15 over 4. So these are different ways you could have done it. So that's the first way, a being 15 over 4. So the answer here, let me just write it. A is equal to 15/4. So let us look at other different ways you could have approached that. Now A, look at this A. Look at the part of P and T, they're on the same line. You can use the concept of collinear points. Collinear, now you can use what you call this analytical geometry to say collinear points have the same gradient. Now remember how to find gradient. Gradient is found by saying m is equal to y2. If I use that, m is equal to y2 minus y1 over x2 minus x1. Remember, this is how you find gradient. So I just want us to find the gradient of 2 points here. The first one, remember O, here it's 0, 0. So we'll find the gradient OP and we'll find the gradient OT. Now, let me write the points. I've got T being minus 8 and 15. I've got P being minus 2 and A. And then I've got O being 0 and 0. So I just want to find the gradient now of these points. Then it will help me to find A. So for collinear points, remember collinear points have the same gradient. So let's find the gradient M of TP. Not TP, M of OT from O to T. It is equal to, now I'll make this my X2 and that my Y2. This will become my X1 and my Y1. So X2 will be 0 minus it's Y2, remember, so it's 0 minus 15 actually, not minus 8 there. So it's 0 minus 15 over 0 minus 8. So it gives me the negative there. I can just use a calculator just to simplify things, to say 0 minus 15, I think that, over 0 minus negative 8. It's simple, give me minus 8 over minus 15 over 8. I think that. Now I can find the gradient M of OP. Now I've got OT, then the next one is to find OP using the same concept, y2 minus y1. So I will use this one as my x1 and my y1 for the second part. So y2, it's 0 minus a over 0 minus 2, and if you simplify this, it will be minus a over negative 2 positive over 2. So you see that I've got two parts now and two gradients, m of OT and m of OP, but remember they are collinear. It means m of OT is equal to m of OP. So I can equate now to say minus 8 minus 15 over 8 is equal to minus a over 2. See that? So that is how you can end up again having that same answer. Cross multiply, minus 15 times 2 is equal to minus a times 8. You are interested in a, so you divide by negative 8, divide by negative 8. So that at the end, that cancels. Now the negative, you can use a calculator straight away to say in here minus 15 times 2 over negative 8, it gives you 15 over 4. So we have got here 15 over 4 is equal to a, and if you still remember, this is the same answer that we got in here to say a is 15 over 4. So guys, it doesn't matter how you solve it, but at the end of the day, it makes you have a similar answer using the concept of collinear points. So that is how you approach this question 5.1. Now let us look at question 5.2. And in this particular question, it says simplify without using a calculator, and they gave us that. Now, if I can do it on a fresh page, just to be able to work it. Now, let us look at this question. As I say, it's question 5.2. This is 7 marks, guys, and you want to ensure that you get all your marks. So it says simplify without using a calculator. So this is what you're given, and you have to use your reduction rule. So for me, usually what I do is I draw my cast diagram here just to be able to remember. This is 0, 90, 180, 270 and 360. So what I have here is 90 minus theta, 90 plus theta, and 180 minus theta. It's always good to do that first before you answer such questions. 180 plus theta, as well as 360 minus theta. Remember, the concept is here, all students take chemistry. Don't forget that. So this is first, this is second, this is third, and this is fourth quadrant. So now let's apply now the question here. So what we're given here is a sine 120. So you ask yourself, which quadrant is sine 120? And you know that sine 120 is in this quadrant, because it's after 90 but before 360. So it is in quadrant number 2, and the reduction rule for quadrant number 2, we're going to use 180 minus theta. So this is same as saying sine, now 180 minus, so I must subtract 180 from 120. So 120 minus 180 minus 120 is minus 60. So the number that I must subtract from 180 to get 120, that number is 60. So if I say 180 minus 60, I get 120. So you see, that is 120, which is still that. So the aim is not to change sine 120, but to find an alternative way of writing it using that reduction rule. That is done. That's the first part. I think for me to have enough space, let me write it from the beginning here to say sine 180 minus 60, just to make it small, and then dot. What about cos? Again, cos 210, so it will be cos. I ask myself, which quadrant is cos 210? So 200 is after 180 but before 270, so it's in quadrant number 3. So the number that I must add to 180 to get to 10, so I must subtract the 210 minus 180, it will give me that number is 30. So I must add, in this case, 180 plus 30, it will give me 210. Right, don't forget your degrees there, times, what about 10, 315? 315 is after 270 but before 360, it's this quadrant. So the question is, what must I subtract from 360 to get 315? So 360 minus 315 is 45, so I must subtract 45. So because that's the reduction rule there, so this is cos 360 minus 45, and then after that one, see, the next thing that I have is cos 27. Now cos 27 already, in a way, I would leave it as, because it's in the first quadrant, so I'll write it as cos 27, and then I've got all over, because I'm working this fast, I just want to show you something, all over, just to divide that. Let's go to the bottom. I've got sine 63. See, whenever they give you these two numbers, one is cos 27, one is sine 63, Let me show you with the calculator. If I say cos 27, because whatever they give you already is intentional, over sine 63, you'll see that I'm getting a 1. So which means cos 27 is equal to sine 63. It will cancel. So which means this is a cofunction. So you can change the bottom using the reduction rule, because there is no way they could have given you cos 27 and sine 63 without any linkages. So what you do, you already use the cofunction to say this is sine. Now 63 is in the first quadrant here. So we subtract 90 minus, look at a number that we can subtract from 90. So 90 minus 63, you see that it will give us that particular 27. So you see that, so 90 minus 27, and then cos 504. Now you can see that 504 is beyond 360. So what you do is, it means you have completed one revolution. So you are now going to say cos 360 plus, because we have completed one revolution, and you find out what must you add. So it's 540 minus 360. So you subtract the first complete revolution and you'll be left with 180, like that. So that if you say 360 plus 180 is 504. Guys, that's how you approach it. Then this is equal to, now you simplify it, sine 180 minus 60, sine is positive here, so it's sine 60 times cos 180 plus 30. Cos 10 is positive, but cos is negative and sine is negative, so it will be negative bracket negative sine, negative cos 30 times, and the next one is cos 360 minus 45. Cos is positive in the fourth quadrant, so it's simple cos 45 times cos 27. Are you seeing that? All over. And then we continue. Sine 90 minus 27. This is a cofunction. Sine becomes cos 27 times cos 360 plus 180, because it's a complete revolution, whether it was cos, whether it is sine, or whether it is 10. The moment you say 360 plus, there is no need to change any sign. You just write that cos 180. If it was sine, you're also going to say sine 180. If it was 10, you're also going to say tan 180, because it's a complete revolution of 360 there. All right. Then we continue to simplify this. So look at this now. We have got some special angles here. Sine 60. Now, in as much as you have to prove that you didn't use a calculator, but I will advise you at this stage, just use a calculator and then find your sine 60, because it is understood you know what are special angles. So you see, sine 60 is root 3 over 2. So here you start writing. They said no calculator, but you are allowed now to use the calculator like that. And then what about cos 30? So if you say cos 30 is root 3 over 2, I'll show you how you use the calculator like that without proving or showing that you use the calculator. Times cos 45. Now let us look at cos 45. If I say to you, I hope it was cos 45. Let me just check something in the beginning. It was 10, not cos, so I don't know why I ended up having cos there. This is supposed to be 10 45. I just changed that question, so it's supposed to be 10 45. So this is 10. All right. Okay, so it's fine. Now we look at 10 45. So it will be 10 45 is equal to 1. See that? So you multiply that by 1 times, look at this, we can cancel out now cos 27 over cos 180. Again, use a calculator there to find cos 180. It will give us -1. So when you simplify this further, what you have is equal to, so square root of 3 times square root of 3 is 3 over 2 times 2 is 4 with a negative. I think that. I think we have, just to be sensitive here, the negative was from that. So now there is a negative. You see, I was dealing with cos. Now 10. This 10, I say 10, 360 minus 45. And this quadrant 10 is negative. So I need to put a negative here. You see negative 45 and negative 1. Just to correct that. So I've got negative 3 times negative 1 over 4 divided by negative 1, which is equal to, the negative cancels the negative, and the answer is negative 3 over 4. You can just use a calculator here just to have an idea what you're dealing with. So what you do is, you've got that, which is root 3 over 2, because you have to use the calculator somehow just to cross check whether you're doing the right thing, times negative root 3 over 2, like this, times negative 1. You see that, over negative 1, just to get what you're getting. You see it's negative 3 over 4. So that is the answer that you get in here when you do the reduction rule. But the always proper thing to do is to come back to this question and have your calculator to say what is the answer here. So what you have is cos 120 times sine 120 times cos 210, and then 10 315, and then cos 27. Always remember to open and close, and then sine 63, close, cos 540. Then you do that, equal to is negative 3 over 4, which is the answer that we also got as negative 3 over 4. So guys, this is how you can get that 7 marks, and I wouldn't want you to lose that 7 marks out of that. So that was that question. The next question here is to prove this identity. I think I'll have to work it at the bottom here. It says 5.3. Prove the identity 1 over, I can use a different marker here. It's 1 over cos theta minus cos theta over 1 plus sine theta is equal to tan theta. Are you seeing this one? It's 5 marks, so we are going to prove that. So how do you prove it? Let's take our left hand side. So what do I have in the left hand side? I've got 1 over cos theta minus cos theta over 1 plus sine theta. I can add this to say what's the common denominator is cos theta bracket 1 plus sine theta, saying that over, so cos theta into that, it's 1 plus sine theta times 1, which is 1 plus sine theta, minus 1 plus sine theta into cos theta 1 plus sine theta is cos theta times the numerator, which is cos theta. Guys, this is how when you're solving fractions, that's what I'm doing here. So it's this into that, you'll cancel that to be left with that, and you multiply with that. That's why it's cos theta. I hope you're seeing what I'm doing. Or in the beginning, it's this into this, so you will cancel that to be left with 1 plus sine theta, which is what I wrote, times the top, which is that one, which doesn't change anything because it's times 1. And the second one, as I said, I repeat, it's that dividing into this numerator. You see, you scratch that, you are left with cos theta times cos theta, which is what I have there. So that is what I'm doing when I'm using those. So now moving on, be careful, don't be tempted now to cancel that. Don't do that. That's wrong. That's wrong. Don't do that, because you can't cancel because of that negative there. So you've got 1 plus sine theta minus cos squared theta over cos theta 1 plus sine theta. There are many ways you could have approached it, I think, at this stage, but one thing you can do is to remember what is 1. You remember 1 is equal to cos squared theta plus sine squared theta. Remember that. That is 1. Then you've got minus cos squared theta over cos theta 1 plus sine theta. You see that? And then cos squared theta there. You can see that this cos squared theta minus cos squared theta, it cancels out, and now you are ready to simplify this to say equal to sine squared theta. Okay, I think I lost something there. Let me just do this properly. So this is what is this represent 1. Let me undo like this and erase it from here. Remember, we said 1 is this cos squared theta plus sine squared theta, then it's plus sine theta. I think that's why I lost, minus cos squared theta. That's what I was supposed to do there. Then I can now move on to cancel cos squared and cos squared. See what I'm left with? I'm left with sine squared theta plus sine theta all over cos theta, and this 1 plus sine theta. Are you seeing that? Then you can factorize here. What is common on top? It's sine theta, and then you've got sine theta. Sine theta into sine squared is sine theta. Sine theta into sine theta is 1 over cos theta 1 plus sine theta. So sine theta plus 1 and 1 plus sine theta is the same. So you are left with sine theta over cos theta here. Now what is sine theta over cos theta? Which is equal to tan theta, and the question was prove that this thing is equal to tan theta. So you have proved it, and this is equal to here the right hand side. So you can say this is my right hand side. So guys, that is how you could have proved this question here without much of a hassle. That is 6 marks, which is good marks. Now let's move on to question 5.4. Now it says determine the general solution. Again, I want to do it here. The general solution, and what you are given here is 3 sine x is equal to 2 tan x. They want you to do the general solution, and for you to do that, it's not also complicated. What you do, convert tan into sine and cos. This is 3 sine x is equal to 2 sine x over cos x. See that? And then from there you are able to multiply. To remove that, you multiply by cos x, and then we multiply by cos x, so that what you have is cos x times sine x, which is 3 sine x cos x is equal to 2 sine x. Please don't be tempted at this stage to say I divide by sine x, I divide by sine x. so that this cancels. Don't do that. You are going to lose sine x, and when you lose sine, then you will lose some of the values. So don't always divide by x, because when you divide by x, you have lost x in that particular part. So what you do, always factorize. Take it to the other side so that it will become 3 sine x. So whenever I attempted to divide, you remember I must factorize. So it becomes minus 2 sine x. This is equal to 0. So you see now I can factorize sine x. When I factorize, I've got 3 cos x minus 2 is equal to 0. Again, there is a temptation here to divide by sine x over sine x. There is a temptation so that you cancel that, and then this becomes 0. Don't do that. You're going to again lose your sine x. What you do, similar to this part, let me show you. Usually, remember, when you've got x minus 1 is equal to 0, what do you say? You say either x is equal to 0 or x minus 1 is equal to 0. So that's what we do here. So you're going to say either sine x is equal to 0 or 3 cos x minus 2 is equal to 0. That is why I say don't lose your sign. You see, there is your sign. So the first one, how do we find x? X is equal to arc sine 0, and then x is equal to, now they say the general solution. So if you say shift arc sine 0, see, it's giving me 0. So it's equal to 0 plus k 360 degrees, where k is an element of z. They always want you to write that if you don't want to lose marks. Now, if I go to my cast diagram, let me draw it here. Quick way just to show you my cast diagram. Remember, this is 0, this is 90, 180, 360, 270, and 360. So we did 0, sine 0, but look at, in the same place of 0, we've got 180 along the same. So that's another general rule will be x is equal to 180, because it's still 0, plus k 360, and again k is an element of z. Why? Because 0 and 180 is on the same line. Even if you say sine 180 like this, sine 180, see, you'll get a 0. That's why it's either 0 or 180. So it gives you that. That is the first part of your answer here. Now what about the other one? We've got 3 cos x is equal to, take 2 to the other side, it's positive 2, divide by 3 here, so that you've got cos x is equal to 2 over 3. Now we have to find x. What is x? X is arc cos. So shift arc cos is 2 over 3. Then it gives us the angle, our reference angles, 48,189 to 2 decimal places, shift setup, and then 6, you put 2 there, it's 48,19. So you've got 48,19, but this is our ref angle there. This is our reference angle. But now what you do to find the general solution, you come back here to say 48,19 is in the first quadrant, so it's in the first quadrant. That's where you find 48,19. So you saw cos is positive in the first and in the fourth quadrant. That's where you find cos positive here, cos positive. In the fourth quadrant, the reduction rule is 360 minus theta. So what you do, that is where your answers are. So you come here now for the general solution of this one. You are going to say, using the reference angle, x is equal to 48,19 plus k 360 degrees. That's the first one. Or you come here, you say in here is 360 minus theta, so you are going to say or x is equal to 360 minus our ref angle, which is 48,19 plus k 360 degrees. I saying that, so which you will simplify to say what is 360 minus 48, 360 minus 48,19, because that is where cos is positive, is 311,81. So x is equal to 311,81 degrees plus k 360. Now with the last condition, don't forget to write, so this is the answer and that is the answer, and then you write k is an element of z. So these becomes the general solutions for this particular question, and you get 6 marks. The total of this is out of 28. I hope guys this was making sense and of benefit to you. So that's how you can solve this question and ensure that you get all these marks. So yeah, use this question as a revision. I'll also bring some more questions of this nature, but for this time I think this will be sufficient for you to prepare for your final exam. Keep watching the channel. As I said, subscribe to this channel so that every time there is a new video that has been posted, you are always notified, and Google always send you a notification that there is a new video that has been uploaded. If it's not for you, it's fine, you can just ignore it, but if it is for you, you can actually benefit from it. And remember, these are called 24-minute lessons. The reason being, the most applicable maximum absorption or maximum concentration that you can try to achieve is around 25 minutes. Anything you do after 25 minutes, yes, you are concentrating, but you are already distracted with many things. So try to watch these videos in 24 minutes pockets, because at that moment you are ensured of maximum concentration. So you can watch it for the first 24 minutes, give yourself a break, come again for the next 24 minutes, give yourself a break. When you're giving yourself a break, do something totally different from school, like just go outside, take some fresh air, a breathe, just do totally a different thing. When you come again, your mind would have reset and you will again have a better concentration of another 24 minutes. So that is why we always advise you guys to go for the 24-minute study, hence the 24-minute lesson. We have come to the end of our lesson. Thank you.